Hello viewers, good morning. You are welcome to Al-Profi Olympiad Mathematics School. So we have this very short question to talk about, but before we go into details of what we have on the board, so have you subscribed to this channel? Kindly like this channel, share this channel and make a comment on this channel so as for us to be able to improve and serve you people better. So the simple expression which we want to simplify is this. So when we observe what we have here, so we are going to see that the item we have in the numerator, that is the basic item which we have in the numerator, I mean this base, and this base, as well as the base I have in the denominator, are in some way alike and are in some way are different. So since they have some differences, so it will not be easy for me to do or to use the same letter to represent them all. Had it been what I have here is exactly what I have here, so the simple thing I should have done there is simply to say that what a letter or a given variable will be used in what in representing them. So since everything I have in the numerator is very different from everything I have in the denominator, so then the easiest thing I can do is I will give numerator different labeling, while the denominator will as well be given different labeling. So in that situation, so I can say my solution. So let P equal to a squared minus b squared, Q here equal to b squared minus c squared, and R as well is equal to c squared minus a squared. So I can also move to the other level by saying x is equal to a minus b, y is equal to b minus c, and z is equal to c minus a. So I will use this one, I will replace every other thing with this. So the expression will now be written in the form p raised to power 3 plus q raised to power 3 plus r raised to power 3. So everything over x raised to power 3 plus y raised to power 3 plus z raised to power 3. Now anything involving power of 3 like this, so what I will simply do is I want to first of all verify what does this addition of what I have here, what I have here, what I have here is equivalent to. Because there is a particular identity, we state that, so let me use this corner for that. We state that p squared plus q, p raised to power 3 plus q raised to power 3 plus r raised to power 3 plus 3pqr minus 3pqr is equal to, so because of the space I'll be coming here, is equal to p plus q plus r into p squared plus q squared plus r squared minus pq minus qr minus rp. So we have an identity which has this pattern. So we want to check whether this thing holds. Then I have to explain this one before we go back into what we are doing. What this thing is telling us is when we have cubic expression of this form, when we have a cubic expression of this form, right, we need to check what we have in the right hand side of this identity. So if any of these items, be it what we have in this bracket, or let me say if any of the two factors of what we have here is 0, what that automatically means is this thing will be equal to 0. And if this thing is equal to 0, what we have here later has PQR here. Later means P cube plus Q cube plus R cube will be equal to 3PQR. So let me know that area once again. So this is a given identity. This is an identity. So whenever addition of P, Q, and R is equal to 0. So what that means is this one being 0, and we can see this one is multiplying this. So a mere fact that this one is 0 automatically changes the whole item I have here into 0. So when the whole of this is 0, what that simply means is PQ plus QQ plus RQ minus 3PQR will be equal to 0. And when it is equal to 0, another way to expressing this thing by saying PQ plus QQ plus R cube minus 3PQR is equal to 0 is simply to state it as P cube plus QQ plus R cube will be equal to 3PQR. So before we go ahead, especially when we have expression combining things like this. It is first important we check the sum of P, Q, and R, right? And we can see this expression which we are dealing with is of this pattern. So it is important before we do anything at all, before we carry out any manipulation, we first of all must check what is the sum of P, Q, and R. And remember, P is this. So we can do that check here by saying A squared minus B squared plus, I want to do the same thing for Q, so which means B squared minus C squared plus my R, which is C squared minus A squared. And when we look at this thing critically, this is positive A, it will cancel this negative A. This is negative B, it will cancel this positive B. Negative C will cancel negative C, meaning summation of all of these things is equal to 0. So when the sum of this thing is equal to 0, so what that thing simply translates to is that our PQR will be equal to 3PQR. So meaning that PQ plus QQ plus R cube I have here will what? So will now be written as 3PQR. So that means what I have here is the same thing as 3PQR over. So we can do the same thing at the denominator level. It is also important we check for the sum of each item I have here, though I've changed it to X, Y, and Z. So let's check the value of X, Y, and Z. So for my X, I have A minus B plus my Y, that is B minus C, then plus the last item, that is C minus A. Let's also check whether these things sum to 0. See this positive A with this negative A cancel out, or it becomes 0. Negative B against this cancel out. Negative C against positive C also cancel out, meaning that addition of all of these things is equal to 0. So when the addition is equal to 0, what that means is this summation here, right, has the value of what? 3PQR. Because this identity made me to realize that addition of 3 cubes, right? Addition of 3 cubes will be equal to 3PQR on what condition? Condition that one of its factor is 0, right? So it also means X, Y, and Z also has the meaning of what? 3X, Y, Z, right? So this can now be broken down into, we know 3 can cancel 3. Here we are now left with, so let me have that here. We are left with PQR over X, Y, Z. Now, what is PQR? Since PQR is not given as part of what we are to do, so now what do we call PQR, or how does PQR come into what we are doing? So it is from this angle. So when we go back to that angle where we have P, Q, and R, and we can see the first item is P. P here is A squared minus B squared. So I will say A squared minus B squared into my Q. You know, remember this time around, it has changed from addition now to multiplication. So it has to be P, the equivalent of P multiplied by equivalent of Q multiplied by equivalent of R multiplied by, what is Q? We can say Q from above is B squared minus C squared multiplied by R. So equivalence of R, right, is what? C squared minus A squared. So we say everything over. Similar thing is what we are going to do. Here we have X. What is X? X is A minus B. So that means A minus B into, what is my Y? Y is B minus C into B minus C into Z. What is our Z? Z simply means C minus A. Now, when we observe this thing now, so we can see there is an identity we can use in dealing with each of these items in the numerator. The one we have in the denominator happens to be in their basic form, so there is no need in worrying ourselves about this. Now, the identity we are going to apply here is what? The one of the difference of 2 squares. So we simply apply the difference of 2 squares. So remember, A squared minus B squared changes to A minus B and A plus B. Similarly to this one, B squared minus C squared means B minus C into B plus C. And C squared minus Z squared is the same thing as C minus A into C plus A. So we say everything over, what is our denominator? So we have it as A minus B, B minus C, and C minus A. So what we have left now is we are going to cut or divide where possible. So we can say A minus B will cancel the A minus B here. B minus C will cancel our B minus C. C minus A will as well cancel C minus A, meaning that the final result we are going to get now is going to be this, this, and this. So our answer is simply A plus B plus C, and what? And C plus A. So this one. So which simply means that the solution, to the expression which we have above is A plus B plus C, and C plus A. So that is it for the simple expression which we have. Thanks for joining the class.